All right, so let's move on to example 2.22, using the properties of the dot product. All right, so if we're given these particular vectors, let's let A have components 1, 2, -3, and B have components 0, 2, 4, and C have components 5, -1, 3, and find each of the following products. So the product of the dot product of A and C times the dot product of A and B times C. Sorry about that. All right, so that's our first one. So this is simply just following order of operations, right? So what this is saying is take our vector A, which we know has components 1, 2, -3, dot it with B, which we know has components 0, 2, and 4. And once you get that scalar, distribute it into C, right? So notice that there's no dot here between our parentheses and C. This is not a dot product, this is a distribution. All right. So our vector C, as a reminder, is 5, -1, 3. So this is what I'll do first, right? That's inside of our parentheses, just like we're used to with order of operations. So the dot product says go ahead and multiply the corresponding components. So 1 times 0, plus then 2 times 2, plus then -3 times 4. All right, and so this is what will be distributed into our vector C. So when we simplify this, we're getting 0 plus 4 minus 12, which is going to give us 8. So we're getting a vector with components 40, -8, 24. So this is a vector. All right. For part B, we're asked to take the dot product of A with the vector C, which has been multiplied by 2. All right, so once again, we want to focus on what's inside of our parentheses first. So our vector A is 1, 2, -3, and we would like to multiply 2 into our vector C, which has components 5, -1, and 3. So we'll do this distribution first. Rewriting everything else along the way. So this now becomes the vector 10, -2, 6. And when we take the dot product of these two vectors, we want to make sure that we're multiplying the components. So 1 times 10 plus 2 times -2 plus -3 times 6 is going to give us -12. All right, and finally, part C, we are interested in the magnitude of B squared. Well, this one's pretty straightforward. So by the property that we discussed of magnitude, this is just the vector B dotted with itself, which means we've got the vector 0, 2, 4 dotted with itself. Giving us 0 squared plus 2 squared plus 4 squared, or 20. Let's go ahead and check our answers. All right, so for that first one, we're getting the vectors 48 and -24. Let's see, how do you mix that one up? -40, +8, and -24. Let's see. Right here. I hope you guys caught it as well. Little things always seem to get us, right? So 4 minus 12 is -8. So that should have been a -8. So that should be negative, positive, negative. Little things always to watch out. All right. So in part B, We got negative 12 as our answer, and so did they. And part C, we got 20, and so did they. Fantastic. All right, so let's take a look at the checkpoint, which I'll encourage you to work on your own. So for checkpoint 2.22, find the following products. For our vector P, which we have components of 7, 0, 2, Q, which has components negative 2, 2, negative 2, and R, which has components 0, 2, negative 3. Okay, so we are interested in the dot product of R and P times Q, and then the magnitude of P squared. All right, so go ahead and pause and work on that on your own.